Hi everyone, welcome to our chapter 13, the LAN configuration. In this chapter, we have here activities that we need to answer using our pocket tracers. But I'll show you that in my another video. So let's start our chapter 13. The wireless router. Remote workers, small branch offices, and home networks often use a small office and home router. These routers are sometimes called an integrated router because they typically include in a switch for wired clients, a port of an internet connection, sometimes labeled as WAN, and wireless components for wireless client access, as shown for the Cisco Meraki MX64W in the figure. This is our figure. For the rest of this module, small office and home routers are referred to as wireless routers. So this is our Cisco Meraki MX64W. The next figure shows a topology depicting the typical physical connection of a wired laptop on the wireless router, which is then connected to a cable or DSL modem for internet connectivity. So this is our wireless router and this is our broadband modem. These wireless routers typically provide LAN security, DHCP services, integrated name addresses translation, and or our NAT, quality of service, our QoS, as well as a variety of other features. The feature set will vary based on the router model. So, log in the wireless router. To gain access to the wireless router's configuration or GUI, open a web browser. In the address field, enter the default IP address for your wireless router. The default IP address can be found in the documentation that came with the wireless router, or you can search the internet. The figure shows the IPv4 address 192.168.0.1, which is commonly default for many manufacturers. A security window prompts for authorization to access the router GUI. The word admin is commonly used as the default username and password. Again, check your wireless router's documentation or search in the internet. So admin's name and password. Basic network setup. Log in the router from a web browser. Change the default administrative password. For our log into the router from a web browser, after logging in, GUI opens. The GUI will have tabs or menus for help you navigate to various router configuration tasks. It is often necessary to save the settings change in a one window before proceeding to another window. At this point, it is a best practice to make changes to the default settings. So this is our how to log in the router from a web browser. Next, change the default administrative password. To change the default login password, find the administration portion of the router's GUI. In this example, the administration tab was selected. This is where the router password can be changed on some devices, such as one in the example. You can only change the password. The username remains admin or whatever the default username is for the router you are configuring. So this is our router password and re-enter to confirm. Next hour, log in the new administrative password. After you save the new password, the wireless router will request authorization again. Enter the username and new password as shown in the example. So, username and we have our password. Change the default DHCP IPv4 addresses. Change the default router IPv4 address. It is the best practice to use private IPv4 addressing inside your network. The IPv4 address 10.10.10.1 is used in the example, but it could be any private IPv4 address you chose. Fifth, renew the IP address. When you click Save, you will temporarily lose access to the wireless router. Open a command window and renew your IP address with the ipconfig/renew command as shown in the example. So this is our command ipconfig/renew, and this is the list of the renew IPv4. And last, log into the router with the new IP addresses. Enter the router's new IP address to regain access to the router configuration GUI. As shown in the example, you are now ready to continue configuring the router or for wireless access. So this is the renew IP address. Basic wireless setup. Our first is view the LAN defaults. Out of the box, a wireless router provides wireless access to devices using a default wireless network name and password. The network name is called the Service Set Identified or our SSID. Locate the basic wireless settings for the router to change these defaults as shown in the example. So this is our network mode. Network name SSID is default. SSID broadcast is enabled as also this one. Change the network mode. Some wireless routers allow you to select which 802.11 standard to implement. The example shows that legacy has been selected. This means wireless devices connecting to the wireless router can have a variety of wireless NICs installed. Today's wireless routers configured for legacy or mixed mode most likely support 802.11a and AC NICs. Configure the SSID. Assign an SSID to the LANs. OfficeNet is used in the example for 3 LANs. The wireless router announces its presence by sending broadcast advertising its SSID. This allows wireless hosts to automatically discover the name of the wireless network. If the SSID broadcast is disabled, you must manually enter the SSID on each wireless device that connects to the LAN. Our configure and channel. The channel. Devices configure with the same channel within the 2.4 GHz band may overlap and cause distortion, slowing down the wireless performance and potentially break network connections. The solution to avoid interference is to configure overlapping channels on the wireless routers and access points that are near to each other. Specifically, channels 1, 6, and 11 are non-overlapping. In the example, the wireless router is configured to use channel 6. So this is our channel 6. Next, our configure a wireless mesh network. In a small office or home network, one wireless router may suffice to provide wireless access to all the clients. However, if you want to extend the range beyond approximately 45 meters indoors and 90 meters outdoors, you can add wireless access points, as shown in the wireless mesh network. In the figure, two access points are configured with the same LAN settings from our previous example. Notice that the channels selected are 1 and 11 so that the access points do not interface with channel 6 configured previously on the wireless router. So our port 1 is using channel 1 and another one is using channel 11, so that the access point do not interfere with channel 6 configured previously on the wireless router. So this is our router, our switch, and our broadband. NAT for IPv4. On a wireless router, if you look for a page like the status page shown in the figure, so this is our status page, you will find the IPv4 addressing information that the router uses to send data in the internet. So we have here our information of router and internet. Notice that the IPv4 addresses is 209.165.201.11 is a different network than the 10.10.10.10.1 address assigned to the router's LAN interface. All the devices on the router's LAN will be assigned addresses with the 10.10.10 prefix. So as you can see, we have here the 209.165.201.11 and the default gateway is just like it. Quality of service. Many wireless routers have an opinion for configuring quality of service. By configuring quality of service, you can guarantee that certain traffic types, such as voice and video, are prioritized over traffic that is not as time sensitive, such as email and web browsing. On some wireless routers, traffic can also be prioritized on specific ports. We have here the basic, advanced home, and our quality of service, priority, and description. Port forwarding. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. However, there are situations when specific ports must be open so that certain programs and applications can communicate with devices on different networks. Port forwarding is a rule-based method of directing traffic between devices on separate networks. So, we have here our single port, applications and gaming, the external port, internal port, protocol, and IP address and enabled. So, we have here the packet tracer activity. I show you this activity on my next video. So, next, our configure a basic LAN on our WLC. WLC topology. The topology and addressing scheme used for the videos and this topic are shown in the figure and the table. The access point AP is a controller based as opposed to an autonomous AP. Recall that controller-based APs require no initial configuration and are often called lightweight APs. LAPs use the lightweight access point protocol, or our LWAP, to communicate with a LAN controller, or controller-based APs are useful in situations where may APs are required in the network. As more APs are added, each AP is automatically configured and managed by the WLC. So this topology, we have reduced server, our FO0, 1, 5, 6, and 18. We have here our G1, our AP1, router, switch, and PCA and B. Of course, we have here our laptop. Addressing table. This is the table that you can use to address everything in your topology. Log into the WLC. Configuring a wireless LAN controller is not that much different from configuring a wireless router. The big difference is that a WLC controls APs and provides more services and management capabilities, many of which are beyond the scope of this module. The figure shows the user logging into the WLC with credentials that were configured during initial setup. This figure is the network summary page is dashboard that provides a quick overview to the number of configured wireless networks, associated access points, and active clients. You can also see the number of ROG access point and clients as shown in this figure. So we have the wireless networks access point, the ROG, interferers, and active clients. View AP information. Click access point from the left menu to view an overall picture of the AP system information and performance as shown in the next figure. The AP is using IP address 192.168.200.3 because Cisco Discovery Protocol is active on this network. The WLC knows that the AP is connected to the fast Ethernet 01 port on the switch. This AP in the topology is a Cisco AeroNet 1815i, which means you can use the command line and a limit set of familiar iOS commands. In the example, the network administrator pinged the default gateway, pinged the WLC, and verified the wired interface. So this is our ping command and our MAC address. And you can see the success rate is 100%, and another success rate is 100%. Advanced settings. Most WLC will come with some basic settings and menus that users can quickly access to implement a variety of common configurations. However, as a network administrator, you will typically access the advanced settings. For the Cisco 3504 wireless controller, click Advanced in the upper right-hand corner to access the advanced summary page. As shown in the figure from here, you can access all the figure of the WLC. We have here one access point supported. IP addresses, service port, management IP address, emergency image, and software version, system name, and uptime. Configure a LAN. Wireless LAN controllers have point and interfaces. Ports are the sockets for the physical connections to the wired network. The assembled switch ports interfaces the virtual. They are created in software and are very similar to VLAN interfaces. In fact, each interface that will carry traffic from a LAN is configured on the WLC as a different VLAN. The Cisco 3504 WLC can support 150 access points and 4096 VLANs. However, it only has 5 physical ports as shown in the figure. This means 5 physical ports. This means that each physical port can support many APs and LANs. The ports on the WLC are essentially trunk ports that can carry traffic from multiple VLANs to a switch for distribution to multiple APs. Each AP can support multiple LANs. So, basic LAN configuration on the WLC includes the following steps. First, create the LAN. Create the LAN in the figure, the administrator is creating a new LAN that will use wireless LAN. As the name and service set identifier, the ID is an arbitrary value that is used to identify the LAN in display output on the WLC. Next is apply and enable the LAN. After clicking apply, the network administrator must enable the LAN before it can be accessed by user, as shown in the figure. The enable checkbox allows the network administrator to configure a variety of features for the LAN, as well as additional LANs. Before enabling them for wireless client access, from here, the network administrator can configure a variety of settings for the LAN, including security, quality of QoS policies, and other advanced settings. Next is select the interface. When you create a LAN, you must select the interface that will carry the LAN traffic. The next figure shows the selection of an interface that has already been created on the WLC. We will learn how to create interfaces later in this module. So, in our figure, we have general, profile name, type, SSID, status, and our interface or interface group. Next is secure the LAN. Click the security tab to access all the available options for securing the LAN. The network administrator wants to secure layer 2 with WPA2-PSK. WPA2 and 802.1x are set by default. In the layer 2 security drop-down box, verify that WPA plus WPA2 is selected but not shown. Click PSK and enter the pre-shared key as shown in the figure. Then click Apply. This enabled the LAN with WPA2-PSK authentication. Wireless clients that know the pre-shared key can now associate and authenticate with the AP. Next is another packet tracer configuration, a basic LAN in the WAC. Next, our configure the WPA2 enterprise LAN on the WLC. SNMP and radius. In the figure, PCA is running simple network management protocol. The remote authentication dial in user service server software is used to monitor the network. The network administrator wants the WLC to forward all SNMP log messages called traps in the SNMP server. In addition, for LAN user authentication, the network administrator wants to use a radius server for authentication, authorization, and accounting, or our AAA services. Instead of entering a publicly known pre-shared key to authenticate as they do with WPA2-PSK, users will enter their own username and password credentials. The credentials will be verified by the radius server. This way, individual user access can be tracked and audited in necessary, and user accounts can be added or modified from a central location. The radius server is required for LANs that are using WPA2 enterprise authentication. So our topology, we have here radius, PCAB, router 1, switch 1, our AP1, and our, of course, WLC and laptop. Click the Management tab to access a variety of management figures. Figure SNMP server information is listed at the top of the menu on the left. Click SNMP to expand the submenus and then click Trap Receivers. Click New to figure a new SNMP trap receiver as shown in the figure. So our step 1, click Management tab to access a variety of management. Second one, click SNMP to expand the submenus, and then click the trap receivers. For last step is click New to configure a new SNMP trap receiver. Configure radius server information. To figure the WLC, the radius server information, first, click the security. Second, radius, the authentication, and click the new. To add PCA as a radius server, Enter the IPv4 addressing to PCA and shared secret. This is the password used between the WLC and the radio server. It is not for users. Click Apply. Each LAN configured on the WLC needs its own virtual interface. The WLC has 5 physical ports for data traffic. Each physical port can be configured to support multiple LANs, each on its own virtual interface. Physical ports can be also each aggregated to create high bandwidth links. So this is our topology. Configure a new interface. First, create new interface. To add a new interface, click Controller, Interfaces, and New. Next, our configure the VLAN name and ID. In the figure, the network administrator configures the interface name as VLAN 5 and the VLAN ID as 5. Clicking Apply will create the new interface. Next, configure the port and interface address. On the Edit page for the interface, configure the physical port number. Our port number is 1. G1 in the topology is port number 1 on the WLC. Then configure the VLAN 5 interface addressing, our VLAN identifier. In the figure, VLAN 5 is assigned IPv4 address 192.168.5.254 slash 24.24. R1 is the default gateway at IPv4 addresses the 192.168.1.5.1. Next, apply and confirm. Configure the DHCP server addresses. In larger enterprises, WLCs will be configured to forward DHCP messages to the dedicated DHCP server. Scroll down the page to configure the primary DHCP server as IPv4 addresses 192.168.5.1 as shown in the figure. Our primary DHCP server. This is the default gateway router address. The router is configured with a DHCP pool for the LAN network. As host, join the LAN that is associated with the VLAN interface. They will receive addressing information from this pool. Next, apply and confirm. Scroll to the top and click Apply as shown in the figure, then click OK. Verify interfaces. Click Interfaces. The new VLAN 5 interface is now shown in the list of interfaces with its IPv4 address as shown in the figure. Next, our configure a DHCP scoop. First, create a new DHCP scoop. A DHCP scoop is very similar to a DHCP pool on a router. It can include a variety of information including a pool of addresses to assign to DHCP clients, DNS server information, list time, and more. To configure a new DHCP scoop, click internal DHCP server, our DHCP scoop, and then click New. Configure a WPA2 enterprise LAN. First, create a new LAN, then go. Second, configure the LAN name and SSID. Fill the profile name and SSID in order to be consistent with the VLAN that was previously configured. Choose an ID of 5. However, any available value can be used. So, click Apply. 3. Enable the LAN or VLAN. The LAN is created but it is still need to be enabled and associated with the correct VLAN interface. Change the status to enabled. Choose VLAN 5 here. Enabled VLAN 5. Apply and then OK. Verify AES and 802.1x defaults. First, click Security, AES, Encryption, 802.1x, and Enable. Configure the radio server. First, click our AAA servers, our IP address, and apply. For our verify that new LAN is available, click back or the LAN submenu, our wireless LAN, and the company name, wireless LAN, copy name. Another pocket tracers. Next, our troubleshoot LAN issues. Troubleshooting approaches. Network problems can be simple or complex and can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This process is called troubleshooting. So this is the step, title, and description. Wireless client not connecting. When troubleshooting a LAN, a process of elimination is recommended. So, in the figure, a wireless client is not connecting to the LAN. Troubleshooting when the network is slow. Upgrade your wireless clients. Older 802.11b, G, and even our end devices can slow the entire LAN. For the best performance, all wireless devices should support the same highest acceptable standard. Although 802.11ax was released in 2019, 802.11ac is most likely the highest standard that enterprises can currently enforce. Then, split the traffic. The easiest way to improve wireless performance is to split the wireless traffic between the 802.11 and 2.4 GHz band and the 5 GHz band. Therefore, 802.11n can use the two bands as two separate wireless networks to help manage the traffic. So this is our topology. This is our home net 5 and our home net 2.4. Updating firmware. Most wireless routers and APs offers upgradable firmware. Firmware release may contain fixes for common problems reported by customers as well as security vulnerabilities. You should periodically check the router or AP for update firmware. In the figure, the network administrator is verifying that the firmware is up to date on a Cisco Macari AP or our access point. On a WLC, there will most likely be the ability to upgrade the firmware on all APs that the WLC controls. In the next figure, the network administrator is downloading the firmware image that will be used to upgrade all the access points. So this is our figure. Are you sure you want to preload a primary image for all apps associated? So we have here the AP virtual IP configuration. We have another packet tracer. So that is all for today's video. See you on my next videos which is the activities that we will use a packet tracers. Thank you for watching.